G'day guys, we've got a trigonometry question today which is asking us to prove that 1 plus cos squared x divided by sine of x take 1 is equal to negative sine of x. Now we're going to use a trigonometric identity to solve this problem here, specifically the trigonometric identity that breaks up cos squared x into sine squared x. So specifically we're going to be using the Pythagorean identity today guys, which is that the cosine squared of x plus the sine squared of x is equal to 1. Now we can manipulate this Pythagorean identity by moving the sine squared x over to the other side. So we have cosine squared of x is equal to 1 subtract the sine squared of x. Cool. So from here, guys, what we're going to do is we're going to replace the cosine squared of x with 1 minus sine squared of x. So let's go and do that. So on our left-hand side, we've got 1 plus cosine squared of x divided by the sine of x subtract 1, which is going to be equal to 1 plus, now rather than writing cosine squared of x, we're going to write 1 minus sine squared of x, all divided by sine of x subtract 1. Cool. So what we can do from here, guys, is I'm going to factorize the top because I can see that this is going to be a difference of perfect squares. So let's get to doing that. So this is going to be equal to 1 plus 1 minus the sine of x in brackets, 1 plus the sine of x in brackets, all divided by the sine of x take 1. So from here what we're going to do is we're going to try and rearrange the denominator so we can then cancel out some of the numerator. Now what I'm going to do that, and this is just a little trick of the trade, is I'm going to multiply both the numerator and the denominator by -1. So I'm going to go multiplied by -1 divided by -1. So that's like just multiplying it by 1. And what I get is this is going to be equal to 1. And rather than writing plus, because the top is going to be minus now, it's going to be minus all the same. And the bottom here, we're going to have -1 times the sine of x, so it'll be the negative sine of x, and -1 times -1 is +1. So I'm going to stick the 1 at the front, so I'm going to have +1 minus the sine of x. So from here, guys, hopefully you'll see that both this and this cancel out, and we are left with 1 minus 1 plus the sine of x, which is equal to, if I multiply out the bracket, 1 minus 1 minus the sine of x. So you can see that 1 take 1 is going to be 0. So this is going to be just equal to the negative sine of x, which, my friends, is equal to the right-hand side. Okay, so the proof in this case has two, I would say, main tripping points, like points that if you can't do these bits, you won't be able to do the proof. The first tripping point is understanding that this is definitely a Pythagorean identity. You must use this when you're trying to separate this cos squared x in the numerator. And the second point is this little trick of the trade here, which is used to make the denominator look like the numerator, so it makes it easier to cancel out. But these kind of tricks, these -1s over -1s and stuff like that, can only really be brought into play once you've practiced these a lot. You'll only be able to solve one of these if you've seen a similar one prior to it, so you know that, oh, hang on, I can make this look like this by multiplying both of them by -1. From there, it's simply cancelling out our like terms, and then we get our solution. So there you have it. I hope you found this video helpful, guys. If you did, please give it a thumbs up. I'm only a new channel, so every thumbs up and interaction with this channel really helps me sort of rank on the YouTube search. Also, if you'd like to see more videos like this, subscribe to my channel. I put out new videos most days of the week. And finally, guys, if you have any problems with this problem or any other related problems, please leave them in the comments section below. I'm always looking for new video ideas and I would love to help. But until next time, guys, just remember to keep practicing, practicing, practicing. If you keep bashing your head against the wall, eventually the wall will fall down. But most importantly, keep enjoying your maths. I'll see you again soon.